4.4 groundwater heat pumps, and in the submodule 4.4, we want to tell you something about practical considerations for successful drilling projects. Of course, we start with the introduction. So, of course, you see here in the groundwater heat pump, we need an abstraction well and an injection well you already know. So what are the requirements for such a successful geothermal well? First of all, what we wanted to have in such a well is a high productivity, a long lifetime, and, if possible, low construction costs. There are some variations of parameters which are important. That's the drilling depth, so how deep do we have to drill, and the well diameter, and the filter section. So a successful drilling project for geothermal heat pumps depends on a detailed planning, selection of appropriate techniques, a risk management, and of course a minimization of environmental impact. You have to do that because also water authorities really look that this is properly done. So in the well drilling process, which steps do you have to follow? First of all, you have to select the site, of course. So the site must be accessible, the geology must be the right one, and also a distance to other constructions or well must be considered. Of course, you have to apply for permits. So due to the local regulations, so you have normally apply for water permission. Depends, of course, in which country you are and what are the rules there. And then you can start the drilling. And the drilling methodology should be appropriate for the site, for the geology, and for the depths you're going to drill. The next step is a casing and grouting. So you line the well with a casing to prevent that the well will collapse. And in the annular space between the casing and your borehole, then you have to fill in with grout to protect the well and prevent contaminations. After the casing and grouting period, you have to do a well development. This should ensure well long-term performance and the efficiencies or high efficiency and also a good water quality. After the well development, you have to test the well. So what is the production rate? You do a well test, we talked about in the lecture before, and then you do a water analysis to say that the hydrochemistry you expected is the right one and it's not any risk for your well and for the use of the geothermal heat pump. And at the end then you install the pumping equipment, the pump and all pipes and what is necessary. Of course, there are a lot of values and parameters to influence your well design. First of all, it's the hydrogeological framework. So what are all geological conditions? If you have a loose rock in the underground, then you have to see what is the grain size. The grain size actually controls later on which filter you should choose and what is the slot size for the filter. And the geology, of course, leads also to your filter length and your drilling depths and so on. So you have to interpret a lot of geology and you have to know about the rocks in the underground that you design then your well in the right way. Also, some technical requirements for the operator are important, like how much volume flux rate you want to have. So how much production you want or you need for your heat pump, what is the dimension of the pump, which filter pipe diameter you have, and also where do you going to drill. So and then the well design technique is the last influencing parameter. So what is your drilling diameter, which casing material you choose, and what is the annular space filling material and so on. So a lot of different parameters which influence your well design here. Of course, first of all, you have to drill. So there are different drilling methodologies, and drilling methodologies are linked to the geology and the depths of drilling in general. So you have to choose the right drilling technique for the specific conditions you want to drill. So this is a rotary drilling. So it's a drilling work and rock destruction through the rotary force with the motor at the top. And there is mud going through this pipe, and the mud will be pressed to the drilling rods to the bottom hole and exits at the drilling bit. And the mud actually supports the drilling process and transports the cuttings to the top. Rotary drilling is used in general for loose and hard rock also soft to medium. Of course, there is also other techniques like down the hole hammer technique. It's a compressed air, so you use air then. It's induced with the drilling rods down the hole hammer and in the borehole. So the compressed air carries the cracked rock and transports it to the top between the rods and the borehole wall. So this is also specific for some conditions, can be used here. Another technique is ramming core drilling. So here you have a valve. This is rammed in the underground and then transport rock material to the top. This is very useful because then you get some material out of your borehole, and this can be interpreted and then transferred to the geology. So you know then directly how the geology looks like, and then this is also very important for your well design later on. By an auger drilling process, which is quite a simple form of drilling, then of course you use that in loose rocks, and it's a continuous transport of the material to the top. And this is normally used for wells in the low depths. And here in this drilling technique, actually material is mixed, and you cannot really link the geology anymore to the really depths. So it's a mixture. So the interpretation of the geology is a little bit more difficult here. So that's all from the drilling techniques in a nutshell. And in the next part, we're going to see how we will design the well.